Hello, welcome to our presentation, Animal Phyla by Abraham Seca. So, also evolutionary relationships. So, we are going to start by showing this picture. So, here we have a big picture of about, I think, 15 or 1, 2, 3, 4, 5, 6, 7, about 10 animal phyla. They are all separated with by tissue, symmetry, cavity, xylem, and like here, multicellularity, tissue, no tissue, bilateral symmetry, cavity or no cavity. Example would be this animal had Telophora, no, not Telophora, platin helmet, body cavity, xylem and pseudocoelomate, protostome or deuterostomes, notochord, and vertebrae chordata. So chordata is the one that we are in, like the animal phyla where human is located. So next slide is about the phylum. Just talking about the phylum Porifera. So there are sponges that have no definite shape, asymmetrical, no tissue or organ. They have a colony of special cell. They don't move, and the skeleton of spongin and spicule. So the skeleton is made of spongin and spicule. So as you can see here, no tissue. Examples of spongia will be this animal, this organism found in the depth of the seas. Yeah. So this is an example of a sponge. So phylum Cnidaria. Those phylum have stinging cell. They are stinging cell animal. Example could be jellyfish, coral, anemones. They have a radial symmetry, two tissue layer with inner mesochela, ectoderm and endoderm, primitive nerve but no brain, two ways of digestive tract, and as you can see, stinging cell for capturing food. So they capture food with the stinging cell. So this is all for Cnidaria. An example of Cnidaria can be this organism right here found in the depth of the sea. Beautiful creature, actually, really beautiful creature. Next one is the phylum Ctenophora. So this phylum is made of calm jellies. They prey, they get the food on plankton. They have a radial symmetry. They are diploblastic, meaning that they have two germ layers, ectodermal and mesodermal. They have a complete gut and two anal pores, and they have tennis. And this tennis allow them to move, to get their food. Like they are used for movement. An example of a ctenophore will be this organism right here. We see all these bubbles on his tail, looking like bubbles. So phylum Nematoda. Nematodes, also called roundworms, are members of the animal phylum Nematoda. So these worms have a complete digestive system and are more complex than the flatworms, but they lack a circulatory system and other advanced features found in annelids, segmented worms. So annelids are segmented worms, and nematodes is here. An example of nematodes right here. The phylum Arthropoda, which comes next billions of years ago after the nematodes came in. So they include insect, crustaceans, centipedes. They have exoskeleton made of chitin, and they must shell to grow, otherwise it will be disturbed. Example of arthropods are crabs and all the other animals. Phylum Platyhelminths, flatworms. They are flatworms, so they are first animal to exhibit bilateral symmetry. So as we saw, animals are differentiated also on symmetry. So those one have started with by bilateral symmetry, three tissue layers, and they include Here an example of flatworms, kind of nasty looking, but it's fine. Phylum Nermita. Rubber worms, they are rubber worms, mostly marine, longest complete digestive tract. They have no body cavity, so acylomate true circulatory system that distributes nutrients, doesn't have a heart. So that's all about Phylum Nermita. Here the example is called tubulins, an example of Nermita, really long. Phylum Annelida, segmented worms. Earthworms, sandworms, leeches, they have one way of digestive system, have well developed digestive and circulatory systems. So Phylum Annelida. Example will be this organism right here. You see, he can be segmented. Phylum Mollusca, soft-bodied animals, include snails, slugs, nudibranch, chitin, limpets, clams, oysters, squids, octopus, nautilus, etc. So they have no shell, one shell, or two shell. Many have hard mouth, like the big hind cephalopods. Example of a mollusca will be an octopus. Phylum Echinodermata, they have spiny skin animal. They include sea star, brittle star, sea urchins, sea cucumbers, and rhinoids. They have reverted back to radial symmetry. The tube feet and water vascular system must exhibit pentamerism. Pentamerism means that they have five, if you want to call it, legs or something along those lines. Here the example of Echinodermata, you see that they have 5 legs, and they are bilateral, so you can separate them in 2 parts. So this is all for Echinodermata. Phylum Chordata, they include fish, amphibians, reptiles, birds, and mammals. They have chordate characteristic, dorsal hollow nerve tube. They have notochord. The example will be this animal called the ratfish of the subphylum Chondritis. So this is all for the phylum Chordata. Another phylum can be the phylum Hemichordata. Hemichordata is a phylum of marine deuterostome building of first animals. Generally, they are considered a sister group of echinoderms. They appear in the lower or middle Cambrian and include 2 main classes, Enteronesta and Pterobranchia. Phylum Chordata. Example will be tongue worm, kind of nasty looking, but that's what it is. So here's again the big picture. Again, we can see that they are differentiated. There is differences as those who can shed the cell and those here who cannot. And we know that annelids, mollusca, and platyhelminth are lophocotyledons, all belonging to the protostomes, which make the mouth first, then Deuterostoma Chordata and Echinodermata. All overall are bilateral except the Ctenophore, the Cnidaria, and Porifera kingdom. So this is the big picture where we can see good differences and all.